Hey everyone, this is Mrs. Moriarty, and I'm here to discuss with us topic 2.5, which is all about natural disruptions to ecosystems. In this topic, we're going to talk a lot about certain types of events that are not necessarily human driven that are going to disturb ecosystems. So, a lot of these are actually tied to what we talked about today in terms of ecological succession. So, any natural disruption to an ecosystem is going to have environmental consequences. In some cases, it could also even have some economic consequences too. But here, looking at some examples of maybe natural disruptions that could take place, can be things like hurricanes, right? A lot of those we have seen, especially in our area. We've seen the environmental and kind of economic consequences of larger, more frequent hurricanes, forest fires, any volcanic eruption, a flood, tsunami, drought, even pests, right, that invade certain areas can all kind of fall into that category of a natural type of disturbance. Now, how often do a lot of these disturbances take place? Well, there are three terms that we need to know. That would be periodically, meaning that these events tend to occur in regular frequency. So, maybe in talking about certain types of biomes that might experience dry and wet seasons. So, maybe monsoons and droughts. Those would be disruptions that happen on a frequency, right? We can kind of predict when those things are going to take place. Things can also happen episodically, meaning that they do happen occasionally, but with a little more irregular frequency than something that is periodic. And then we can have random, right? There's really no regular frequency whatsoever, just kind of comes up, and ecosystems have to deal with it. So that can be maybe a volcanic eruption, earthquake, maybe even an asteroid hitting Earth. That would all be under random types of events. Now, one type of event that is, obviously been happening and it is continuing to be ongoing, and it is a main theme in this class, is the disruption of climate change, right? So how has Earth's climate naturally changed, right, over time? We can see in the graph to the left, carbon dioxide and temperature has a very close relationship with one another, right? Carbon dioxide levels being blue, red being our temperature, and you kind of see it goes in a very cyclical type pattern for many, many, many years, where we see periods of lots of carbon dioxide usually signifies higher temperatures, lower CO2, lower temperatures. But now, what we're finding when we look at more of that present day scale, we see that the carbon dioxide trend has greatly increased, which only really means that temperature is going to follow suit. So over time, Earth's climate has varied. It is something that naturally does occur. But the issue with the climate change that we continue to see today is it is happening at a much faster rate due to human influence. Now, what has changed this level of CO2, changed this temperature? Sometimes we can see slight changes in Earth's orbit or even their tilt. In change in orbit and tilt, that can manipulate how much sunlight is hitting certain parts of Earth, which means we can see maybe mini ice ages or even warmer periods, especially if Earth shifts slightly closer or further from the sun. These are actually known as Milankovitch cycles. So in turn, if Earth's climate has changed, then that means, right, sea levels are going to change over time too, right? Our sea levels are going to be very tied closely to a lot of the global climate patterns that we see around the world. So we can see, right, sea level, just like temperature, has varied over geological time periods, especially if we're experiencing more of an ice age period. We're going to have a lot more glacial ice versus areas and where we're going to have warmer periods, then we see more melting forming. But what this can eventually do over time, if we continue to see more and more of that melting at a faster rate than what it has occurred prior, we can see a widespread habitat change, and that means species in those habitats are going to have to adapt very rapidly, and not every species has that ability to do so. For example, if we see continuous rising sea levels, areas like coastal, mangrove swamps, or even estuary type habitats could experience floods. So now they're going to be covered in water for even longer periods of time than they normally are throughout the year. And that's going to obviously impact maybe even the range of tolerance of the species that reside there. And in speaking about range of tolerance, we know that if organisms move into that physiological stress range or even zone of intolerance, we're going to, unfortunately, wind up seeing a lot of extinction. So then how does climate change affect wildlife, right? So with the change in temperature, precipitation patterns, sea level change, this is obviously going to have a great impact on organisms that depend on migration. Oftentimes, organisms that migrate usually pick up on temperature cues, right? Changes in the climate that signify for them to migrate at certain times of the year. So if those are only going to continue to change, we're going to see migration timing change as well. So for example, wildebeests, right, migrating to follow rain patterns of the African savanna may wind up happening at different periods of time of the year. And when those species arrive to that area, right, to maybe now mate, which is what usually a lot of them do, there may not be as many resources there at that period of time, and so we're going to see maybe a decline in the population. Ocean species that tend to move further north as water temperature warms. Once again, if that's going to rise and warm, we're going to see their migration shift up as well. Even bird migration, same thing, right? We see the breeding and shifting happening a lot earlier in the year than what they would normally do several years ago. And so all of this shift in climate, temperature, precipitation, sea level change is all going to have environmental implications, and in some cases can have maybe even economic consequences too. All right, guys, here is our practice FRQ for 2.5. Here the graph shows us data about 3 tree species after, let's say, a glacial type of retreat. Identify the type of event that would occur after a glacial retreat. So this is kind of tied to what we just did in class today. Take a moment, pause the video, and answer the question. Okay, at this point, we should have answered our FRQ. So what kind of event would take place after our glacial retreat? That would most likely lead to primary succession, right? So we can see time and years after our glacial retreat, we start to see an increase in certain types of tree species here. And over time, that tree species declines, right? That's due to competition until we wind up reaching, it looks like, the most complex species in this ecosystem specifically would be your hemlock, since they're going to be mostly dominant 200 years after that glacial retreat. All right, everyone, that's it for our video on 2.5. If you have any questions, please leave that at the end of the video.